everyone. I'm Professor Caudill, and today we're on vectors still. So I think last time we did an attempt at this problem of a particle entering a magnetic field. So we're trying to calculate this force vector that happens here. And this is direction of the particle. And this is your force vector. So we're given the components of U and the components of B. Okay, so first we find U cross B equals F over zeta. Okay, magnitude F can be found with the components. So when you take cross product of two vectors, you get another vector. So in the latter approach, we have to find the angle between U and B. When we know the force, general method is to find the direction angle. To compute the vector product, you can use 2.4. So we're going to break F down into the components of this. So zeta so here's how to think of it. So U is 5, -2, 3.5. That's the vector U. Where, I mean, you could think of it like this vector multiplied by X, Y, Z if you want. And we're taking this cross 7.2, -1.0, -2.4, and same thing, there'd be a little XYZ. So we're going to take 5 times 5 times 1. That's going to be 5 minus okay, so I want big brackets here. So it's going to be 5, excuse me. So 5 minus 7.2, right? Yes. So 5 minus 14.4. And that is your Z. Okay, so we're doing it like, so it'd be 5 this times this minus this times this. Okay, that's the first cross product. Okay, now what's the next cross product going to be? It's going to be 2 times negative 2 times negative 2.4, which is going to be 4.8 minus so this minus 3.5. So it's going to be plus 3.5. So that's going to be our x. 8.3 zeta. And then our f y is going to be 3.5 times 7.2 minus 5. So 5 times 2.4. Okay. So you might be wondering why I'm doing it in this order. It's because I'm familiar with the linear, like the very abstract linear algebra cross product, where you're taking where it's something like this. A, B, C, D, A, B, C, D, E, F. So I'm familiar with the cross product where it's like this minus this, and then this minus this. And then if you kind of think about it like it's repeating, then it would be this minus this. So in another way, this is A and this is B. A cross B is, let's say, the Z component will be A E minus B D. Then the X component is going to be BF minus CE. And the Y is going to be CD minus AF. So when you're doing the cross product, you gotta think, you just gotta start with Z. So it's ZXY if you're doing it this way. So now we know fx magnitude is 8.3 zeta. Fy okay, so the magnetic force is F. So Force is 8.3, so we can factor out the zeta. 8.3 I hat 19.4 K hat. So we know the force. So we have found this by knowing U cross um, B. So let's say, let's draw it like this. U So we found F by finding the cross product of these two. Um, okay, so if we want to find the magnitude, take the Pythagoras theorem, equals 24.9 zeta. Okay, so now we want to find the angle. So to do this, we find the magnitude of B. And then F times B is going to be so this is so if F, so that's the same as saying 8.3, 13.2, 19.4, IJK dot the components of B, 7.2, -1, -2.4. Okay, so that will equal 8.3, 7.2 plus 13.2, -1 plus 19.4, -2.4, and the book is getting 0. So that means they're perpendicular. Okay, so now that you know the dot product, you can do the cosine -1 of 0 over F times B. That's 0 equals 90 degrees. Okay. So here's where, so what if we're doing cross 0, 0, 4.5. So this is IJK. I'm just gonna omit those. So what's the cross product of these? It's going to be -5 times 0 minus -2 times 0, okay, which is 0. So that's going to be my z. Okay, now the x is going to be -2 times 4.5 minus 3.5 times 0. That's going to be -9 equals fx. Now the y will be 3.5 times 0 minus -5 times 4.5. Okay. So I'm getting a 0 in the I. Okay, so maybe I'm wrong. Maybe it should be, maybe these should be 1. So let me try. Okay, in this case, fz is going to be -5 minus +2. Okay, do we have -3 anywhere? -5 +2. Yeah, I'm not sure if the book's made a mistake or if not, because it looks like it's doing. Looks like it's doing. It's like skipping one. Looks like it's doing this when it should be this. Okay, maybe we can rewrite it. So zeta I guess we could distribute it, right? So -5 I hat cross 4.5 k hat plus, is that what they're doing? Okay, and then the book seems to be doing -5 times 4.5. So I is what? I is 1, 0, 0. K is 0, 0, 1. So if we're crossing these, we should get a vector. We should get 0, 1, 0 because this is I, this is K. If I recall, I cross K should be J hat. So let's do it. Equals 1 times 0 minus 0 times 0 plus 0 times 1 minus 0 times 0 plus 1 times 1 minus so we did this, we did 0, 1, 0, 0, so it would be 1, 1 minus 1 minus, no, it would be 0, so this would be 0, this would be 1. So cross, 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 0, 0 minus 1, 1. So maybe it's a negative J. So the first one should be our Z. And that doesn't make sense. Let me see what I cross K is. I cross K is negative J. Okay. So this should be J. So the order should be, what, this is X, this is Y. Okay. Really, this should be this should be the third. No, this should be the second. Which it would be the second. If we move this under here, then our vector would be 0, -1, 0. Okay, so I think I just proved. So this is actually a negative J. this is actually -1. Okay, so I'm satisfied. So this is going to be -5 times 4.5 times -j hat. All right, so what about, okay, so what about -2 times 4.5 j cross k. Okay, j is 0, 1, 0, cross k 0, 0, 1 equals 0 times 0 minus 1 times 0. Okay, and then that's 1 times 1 minus minus 0 times 0, and then it's 0. So we should get 0, 1, 0 equals we have to move this because remember the first cross is z. So the order is actually k so if we have to reorder this to I, J, K. So it would be 0. It would be 1, because I would be first. 0, 0. Okay, so I just proved I hat equals J hat cross K hat. So the book doesn't teach this, and it is tedious, but it makes more sense to me. It's like it's either you know this or you just memorize that it's, you know, A, Y, B, Z minus U, Z. You have to memorize like Y, Z minus Z, Y for the X, C, X minus X, Z for the Y. I don't know, this seems easier, even though you have to like do all this extra work. This makes more intuitive sense to me. So the scalar product is this particular. All right, so then they took, so I'm looking at part B, I'm looking at everything that's under this line, this equation. So they're distributing this across this. So we've demonstrated J cross K. What about K cross K? So that is 0, 0, 1 cross 0, 0, 1. And the answer is going to be something, 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 A, B, C, and that's going to be K hat. So 0 times 0 minus 0 times 0, 0 times 1 minus 1 times 0. Okay, and then 1 times 0 minus 0 times 1. Okay. So this is obviously 0, 0, 0. And we can rewrite this just for clarity's sake. So that's a 0 vector. So that means this whole section just drops off as they put the 0 here. So it's a negative j. You can pull out the -1 here. So you'll get I, a 2, an ij. Okay. So it's a different approach than I originally thought. So yeah, I still wonder why my first method didn't work. So we had okay, so I think maybe why it didn't work last time was because I thought I had the order backwards. So let's cross these. So my K direction should be -5 times 0 minus -2 times 0 equals 0. 0 minus 0 equals 0, which is what the final answer says. Okay, now the I at should be -2 times 4.5 minus 3.5 times 0 equals -9. And that is what the book got. So, and then J is going to be 3.5. So this is J. 3.5 times 0 minus 5 times 4.5. So 22.5. So when you know what you're doing, I think my method's easier than distributing out the cross. Then you can just do, yeah, you can just do that. That seems a lot better than what the book's doing. All right, so yeah, even without actually computing it, we can predict. It's obvious because of the way this vector is constructed. So we could have predicted it was perpendicular by definition. Okay. All right, check your understanding. Two vectors. A equals negative I hat plus J hat. B equals 3I hat minus J hat. Okay. So we want to find A cross B. All right, so easy enough. Negative 1, 1 cross 3, negative 1 equals A, B, and it should be J, I. Okay, so let's do that. Equals negative 1 times 1 is 1. Okay. So negative 1 times 1 is 1 times 1 minus 1 times 3. Okay. And then B J hat equals B I hat I hat. So it's going to be 1 times 3 minus negative 1 times 3. So negative 3 minus 3 minus minus 3. So 3 minus minus 3, 3 plus 3 equals 6. 6 I hat, and we have negative 2 J hat. Okay, so A cross B equals 6I minus 2J. Did the book get that? Well, let's keep going. So is it using that for magnitude, the absolute value signs for magnitude? Doesn't matter. We know. Okay, I see what. So the is it? I think some books might do double, or maybe that's the norm. The norm should be that though. Let me look this up. Is the norm the magnitude denoted as two vertical lines? Yes, so the norm is that the magnitude or like that. Okay, so yeah, some people write it like this. Equals 6 squared minus 2. So 36 plus 4. Square root of 40 is our magnitude. And we want the angle between A and B. All right. angle between A and B. I think I remember how to do this, so that is -1. Maybe a picture will help. So we have -I plus J. So should be like this is A. And then B 3x minus J. So we want to know the angle of this. Okay, so we're going to have a negative angle here. No. Yes. So we'll have a negative angle. This will be a negative angle. And then this will be a positive angle. I'll say this is theta, and this is alpha. So the final answer should be negative theta. Should be alpha. Alpha minus negative theta. So it'll be alpha plus theta. So like one way to think, like I could see you could like just convert this into where the bi minus j is sits on the x-axis. Um, yeah, so it should be alpha, which is positive, plus this negative angle. Okay, so we need to find the angle of A. So that would be -1. Ah, maybe I do the dot product. So that's -1 times 3 minus 1. -3 minus 1, -4. -3 minus 1 is 4. Okay, so the angle is going to be cosine -1, -4 over the magnitudes of each. So that's going to be, I need more space. So the angle in between is going to be cosine -1, -4 over square root of -1 times 3 -1. Okay, so I think this is the angle between A and B. In radians. That's in radians. we'd have to times it by 180 over pi. I think 180 or pi over 180. We'd have to do one of those. So, and it doesn't let us check our answer, but I think we're somewhat confident. So, key equations. We can probably, I think this is, so this is the end of the chapter. Then there's probably going to be questions, but we can review these key equations, and then next video we can start the homework questions. So multiplication by a scalar. So all right, the components. So direction angle of a vector on a plane. Okay, so this is probably an important one. So if you have A, and you know if you know AX J AX J hat, which is this, okay, and then you know AY. I got these mixed up, didn't I? And then you know AY J hat. You can mirror this over here. So you want to know the direction of this theta, then it's theta A is inverse tangent of AY why is this true? Because tangent theta A is opposite over adjacent. So this is your adjacent, this is your opposite. Opposite because you're moving this over here. And that's just basic symmetry from geometry. Okay, so if you know the magnitude of A, then you can find AX by doing and you know the angle. So if A, let's say we have A equals 20, OA equals 180 degrees. No, I'm sorry. 45 degrees. Then you could say cosine 45 equals SOHCAHTOA opposite adjacent, I'm sorry, equals ax over a. So you can rewrite this as a cosine, which is 20. Opposite, I'm sorry, adjacent over hypotenuse. So you can rewrite this as this. And if you have to make sure your calculators in radians converts double check this, but I think that's it, because yeah, I think that might be right, but double check me on, it might be swapped 80. I get those confused a lot, but it'd be something like that, equals ax. And then similar thing, sine theta is ay over a, because sine, so we have a, we have an ax, say we have this vector, we know ay, we want to know theta, or we know theta, and we know ay, the component of this vector. Remember, this vector a, it can be expressed as a sum ay. Axi plus ayj. Okay, so if we know the magnitude of a is 20, so is opposite, so we mirror this. So is opposite over hypotenuse, which is, we don't know a, y, but we know a, 20, sine 45, so ay equals 20 sine 45 degrees. All right. If they're equal vectors, all the components are equal. If you need to find the unit vector, you take the vector divided by the magnitude of itself. So the book is really insistent on a dot b equals ab cosine phi. I prefer a dot b equals the sum of I equals 1 to n of a n bn. Where a equals and likewise with b. I prefer that definition dot product. So yeah, dot product can be distributive. So this is so you can rewrite the dot product as the sum of the components, which is what they're doing here. So they're really using two definitions. So cosine of the angle between two vectors. Again, that's cosine -1. Theta ij, jk, ki equals 0. All right, a lot of text here. We got 5 minutes. I'll try to find what sticks out to me. Um, it's mostly review. Probably should spend more time on hopefully the homework, lesson, exercises, whatever you want to call it. Hopefully they can give me more intuition on the polar coordinate system. Okay, so is this is that right? Um, can you multiply two vectors? Yes, there's what if I want okay, so I think earlier you might have seen me do something like you have a vector 4, 1, 2, and you might have seen me notate it like this. I, J, K. So one way of thinking of it is like this. I dot this. So that's 4I plus J plus 2K. So I might have omitted the dot, but just know that that's what I meant. It's doing this. So yeah, I just wanted to clarify that. Both kinds of multiplication. So yeah, let's see what sticks out. All right, so here's our conceptual questions. We got, how many do we have? I think last time we did 80. So yeah, they have 80, 91. So we're gonna spend the next couple of videos doing these 91 problems. Shouldn't be too bad. So yeah, thank you guys for hanging out, and I'll see you next time.